Alright, for this explainer, we're diving into some really clever engineering sketches. They lay out a system that's designed to solve a problem that's, well, been around for ages. How to make your home fireplace way more efficient.
I mean, really think about it. You've got this beautiful, roaring fire going, right? But how much of that amazing, cozy warmth are you actually feeling? The answer, you might be surprised, points to a huge flaw in a design we've been using for centuries.
And yep, here's the culprit. This sketch shows the problem perfectly. The vast majority of that wonderful heat from your fire just becomes exhaust. It shoots straight up the chimney and poof, it's gone. Wasted. It's basically like leaving a window wide open in the middle of winter. So how do you fix that? Well, you don't just let all that precious heat escape, you trap it. And that brings us to this very smart solution, the chimney-mounted heat trapping system.
Okay, so let's get into this diagram. I know, at first glance, it looks a little complicated, but the idea behind it is incredibly elegant. This whole thing is designed to sit right inside the chimney and basically ambush that hot exhaust before it can get away. To really get how this thing works, let's break it down into its 5 key parts. You've got the wire frame holding it all together, the modules that do all the heavy lifting, the copper tubes that are crucial for heat transfer, a small fan to move the air, and some special walls to keep all that warmth contained.
First up, you have the foundation of the whole system, the steel wire frame. Just think of it as the skeleton, you know? It's this sturdy, rigid structure that everything else gets mounted onto, making sure the whole setup is nice and secure right inside the chimney.
And now we get to the real heart of this invention, the exhaust modules. See, the hot smoke from the fire is forced to snake its way through these things, and inside each module you've got these copper tubes that are designed to just soak up as much heat as they possibly can from that passing smoke.
So we've met the players, the different components, but what's the actual process? Let's follow the path of the heat and see how this system actively snags that energy and puts it to work warming your home.
It's really a simple and super effective 4-step process. First, the hot smoke flows into the modules. Second, those copper tubes get incredibly hot as they absorb all that thermal energy. Third, the heat-reflecting walls bounce any radiant heat back into the system, which really concentrates it. And finally, a fan actively pushes that captured warmth right out where you want it. This really gets to the core physics of what's happening. The whole concept hinges on what the sketch calls smoke heating, that direct transfer of heat to the copper tubes. That heat then gets trapped by the heat-reflecting walls, which basically creates a little superheated chamber right in your chimney. And see, this system isn't passive, it's an active heater. That low-power exhaust fan is the final crucial piece of the puzzle. It takes all that hot air that's collected around the copper tubes and forces it out into the room. This effectively turns a leaky chimney into a pretty powerful convection heater. But honestly, beyond its ability to just trap heat, the most innovative part of this whole system is its structure. This isn't just a one-size-fits-all box. It's something way more clever. The entire concept is built on what's called modular design, and put simply, all that means is that it's made of smaller, standardized parts, the modules, that you can combine. Think of them like building blocks that let you create a larger system.
And this is where the design is just brilliant. The labels right here in the sketch say it all. Modular design leads to a chimney height customizable system. Got a taller chimney? Just add another module. A shorter one? You use fewer. It's completely adaptable.
So the whole point boils down to this really simple equation. The more modules you have, the more copper tubing you have. That means more surface area to grab heat from the smoke, which means you get greater efficiency. You can literally scale the system's power to your exact needs. I mean, when you put them side by side, the difference is just stark, isn't it? A traditional chimney is fixed, with a standard, pretty inefficient design. This modular heat trap, it's customizable, its efficiency is scalable, and it adapts to your space instead of being a one-size-fits-all compromise. So what's the big takeaway here? Why does this matter? Well, this isn't just a cool drawing. It's a design that could directly lead to reducing energy waste and, lowering our heating bills. It's a practical, scalable solution that could work for all kinds of different homes, and it's just a fantastic example of smart, accessible engineering. And that kind of leaves us with a pretty fascinating question to chew on. By rethinking a design that's been around for hundreds of years with a simple, modular approach, could this kind of customizable efficiency be the future of how we heat our homes? It's definitely something to think about.